Good morning, everyone. Thanks for joining. We're going to give everyone about one more minute to join, and then we'll go ahead and get started. So thanks again for joining. All right, we'll go ahead and get started. Thanks again to everyone that has attended events in the past, and thank you to those that are new today. We have a great presentation by Claire Hessmer on operation and maintenance strategies for the Michigan CNI Energy webinar series. My name's Fred Seiler. I work here at Clear Result, and I'll be walking us through the agenda, a couple of background housekeeping information, and then I'll pass it off to Claire to finish up the presentation. Um, Today we're going to go over our sponsors, additional educational opportunities that are available to SEMCO and Efficiency United contractors. Then we're going to go into Claire's presentation, and then we'll have a quick live Q&A session. So if you have any questions, make sure to put them in the chat bar to either the left or the right. There's a little bar where you can put in your questions as we go through. And as a reminder, we'll have a recording of this presentation up on the website at mienergyconference.com. And if you have any questions after, please feel free to reach out. There's a chat bar right in the website that you can submit questions to, and we'll definitely loop you into the right person to get those answered. So first off, a thank you to all of our sponsors. Again, as I've said in the past, we really couldn't do this without our sponsors' help and their continued support, even through this blip of a year and the changes that we've had to make. Usually we do this in person, and we're doing this as a webinar series. So thank you to our sponsors. We have Consumers Energy, SEMCO's Energy Waste Reduction Program, Efficiency United, UPCO, and DTE. Again, we can't say thank you enough to our sponsors for continuing to support us. So if you want to learn more about energy efficiency and kind of some more of the business side, there is this opportunity with Mark Jewell, who's well known within the industry. He's leading a 6-part webinar series on Thursdays between 1:30 p.m. and 3 p.m. The next session is this Thursday on October 29th. The topic is generating new business. So a really good and interesting topic for the upcoming years. We may see some challenges. There's a lot of activity right now, but this is a good opportunity to see what Mark has to say and how it could help your business. The program is about $588, but for registered trade allies with SEMCO's Energy Waste Reduction Program and or Efficiency United, we're providing it at no cost. So if you have any questions about that, feel free to drop it in the chat and we'll connect you with the right person, or go to our website and you can sign up. We do have a link, or you can just go directly to their website at sellingenergy.com/Michigan. Again, for those that have attended at least 2 or more webinars, you'll get a free grill kit in the mail, just to thank you for continuing to support us and continuing to take advantage of these opportunities. We'll be mailing these out in mid-December, so if you have any questions about that, just let us know. And we're hoping to get some additional materials from our speakers and some of our sponsors. So stay tuned. We'll be reaching out for your delivery address here soon as well. Without further ado, I'm going to pass it off to Claire. Claire is an energy engineer here at Clear Result, and she's a registered professional engineer in 2 states, holds a master's of engineering, a bachelor's of science, and a bachelor of arts, all from Cornell University. So with that being said, take it away, Claire.
Good morning, you guys. Thanks for making a little time for me today. So what I do at Clear Result is actually train people. It's my job to, take your average energy engineer who's really good at walking up to a chiller and saying, if I replace it, it's going to, save this many kilowatt hours a year, and here's your right replacement unit, and get them to see the 15 things that they missed on their walk over to the chiller to look at it. So, these are very, very smart people, but learning to see low no cost energy efficiency opportunities is kind of tricky, right? So, if you want to click forward, Frederick. So what I want to do today is kind of give you guys an overview, and it's just an overview. I could talk about this stuff for hours. Give you guys an overview of the toolkit that I give my engineers. So we're going to go over a framework that's called the 9 energy wastes. Go through some miscellaneous tips that I provide for finding low no cost stuff. And then go through a kind of root cause analysis technique called the 5 whys. And then probably get to what you were expecting, which is kind of system specific, kind of top 5 efficiency opportunities for HVAC, chillers, refrigeration, boilers, steam, and compressed air. And then we should have some time for questions at the end. So make sure you're kind of jotting those down as you go through. If you want to click to the next, Fred. So I have a friend who calls an energy audit reports dust collectors, because so often people get audit reports and finding the opportunity was really easy, but doing something about it turned out to be really hard, right? So as we go through all of this finding the opportunity stuff, I want you guys to be thinking about how you would actually act on it, all right? So that follow through step. And when you think about the follow through step, don't just think about following through once. Think about anything that it would take to make that follow through continue to happen over time, right? Think air leaks. Knowing that you got a bunch of air leaks is easy. Fixing them once, hard. Creating a recurring cycle of fixing air leaks, finding them and fixing them every quarter, say, or every 6 months, that's harder. But it's also what's going to get you those full savings that you want to see out of that first opportunity, right? Out of finding that opportunity. So let's move on, Fred. Okay, so the 9 energy wastes is a framework for thinking about energy efficiency that is based on the 7 lean wastes. So a manufacturing kind of framework for thinking about efficiency. And it's got some industrial components, but it also applies pretty well to commercial buildings. So if you're out there and maybe you're a property manager, or maybe you don't really deal with industrial stuff very much, hang in there. I'm going to mention some industrial stuff, but it's going to have some applications in commercial too. So let's look at what those wastes are. So this is another place where I could talk for like 45 minutes. I actually do a 45-minute workshop on this stuff, but I'm just going to give you the high level view today and then let you kind of take that and digest it at your leisure and see how many of these apply to you. So my favorite is the one at the top left there, unnecessary running or idling. If you make a pie chart of our SEM savings, I would say 40 or 50% of it is just turning stuff off. Turning stuff off. So unnecessary running or idling, some examples I could throw out would be maybe a conveyor that gets left on every night, even when a manufacturing process is shut down. It just kind of sits there and spins, right? Not a big load, but it adds up because of all the extra time it's running. If you're a commercial office building, maybe that's a bunch of computer monitors that get left on with the little screensavers, even though monitors don't need screensavers anymore. And it does that all night and all weekend, right? Leaks, going over a little bit, that's another one of my favorite ones. Now, when I say leaks, I don't just mean like water leak or compressed air leak. Think about thermal leaks too. So maybe you've got a bunch of uninsulated piping somewhere that's just dumping heat or sucking in heat, say, if it's supposed to be cold. That's an efficiency opportunity. Friction loss. That's another one that sounds kind of simple, right? Like, okay, I must have water flowing through a pipe somewhere and there's some resistance to flow. By friction loss, we actually mean a lot of different kinds of flow. So think thermal energy too. So if I've got, let's say, a rooftop unit that's got an air-cooled condenser on it, and with all those little cooling fins, and that thing is caked with like cottonwood fluff and dirt and grime, there's a lot of resistance to that poor thing rejecting energy, and it's running too hot and it's using a lot of extra energy. So friction loss can be a real boogeyman there, but think about it broadly. Suboptimized efficiency. Not my favorite term, but it's a nice catch-all bucket for any situation where the equipment you have and the way you're running it is just not right for the job. So think, you've got a 25 horsepower pump and maybe it's the job it's doing would have been much better for like a 5 horsepower pump. And so the poor thing is just way off its best efficiency point. It's struggling kind of to meet the load in an efficient way. That's one of those sub-optimized efficiency times when you might just need to find a different piece of equipment, or you might need to sequence things differently to get the best efficiency out of your system. Now the middle one, malfunctions. That seems really big, right? But I can think of a few examples to just demonstrate to you how important malfunctions can be for decreasing energy efficiency. So think of, let's say, a bunch of exhaust fans in the roof of a manufacturing facility. And at some point, people got behind on preventive maintenance and belts started breaking. Well, people are still turning those fan motors on, right? Like the fan's actually doing something. Motor's spinning, fan's not spinning anymore, right? Or maybe you're a commercial office building and you've got an outside air temperature sensor that is controlling your whole building automation system. Like that thing is telling all your economizers when to open and close. It's telling your chillers whether they should come on or not, your boilers whether they should come on or not. And that sucker's 10 degrees off. Whoops. None of those decisions are going to be made in an efficient way because of one silly little sensor that was wrong. So be very aware of malfunctions. They can really kind of bite you in a way you don't expect. A system imbalance. So we're all the way over on the right, one down. System imbalance is anything that's kind of operating at some kind of peak design worst case scenario. And most of the time it's not peak design worst case scenario. So think of maybe a VFD that's been overridden and it's operating at 100% because there was some kind of incident and somebody thought they needed full flow and they never came back and undid it, right? You might be seeing full flow and you don't need full flow. This could be, say, a programmable thermostat that's been overridden or never scheduled, right? So overnight, your HVAC system is aggressively targeting an occupied set point and it doesn't need it. It's not a design occupancy or a design loading condition, right? So beware of those system imbalance moments. Misapplication. So we're down on the bottom left there. Misapplication is kind of using a more energy intensive way of doing the job. So say you're using compressed air for cleaning when a leaf blower might do the job, right? Or say you're using steam for something when hot water might do the job, right? So you're using a more energy intensive way of doing something. Underutilization is the next one. So underutilization is, something like a process bottleneck that causes downstream equipment maybe to run kind of underloaded or with half-size batches or to idle a bunch kind of between slugs of product from upstream. So it's any situation when you might be able to look at the big picture and say, let me resequence that. So think about underutilization again, kind of in a broad way. I can't think of a good analog for commercial buildings right now. This might be one that's more on the process side. And the last one I'll throw out there is traditional lean waste. So if you're in any kind of manufacturing environment, you've heard of lean principles, right? So scrap reduction, reducing excess product movement, all that kind of stuff. Usually those have ancillary energy efficiency benefits. So don't ignore those traditional lean waste opportunities just because they're not energy efficiency opportunities. They're just hiding. Okay, so Frederick, let's move on real quick. What I'm going to do is throw out some tips, but before we really get into this, take a second, grab a piece of junk mail or a piece of scrap paper or a Post-it, and just take one efficiency opportunity that you thought of on that last slide, because I know you thought of at least one, and write it down so that after this we can actually do that like following up part that we were talking about. So take 15 seconds and see if you can write something down that you would want to follow up on. Alrighty, I'm going to trust you that you wrote it down. So I'm going to throw out my generic tips here on finding and seeing low, no cost energy efficiency opportunities. Don't forget behavior. So all of this equipment has people who have to make decisions about how to run it and how to interact with it and how the end uses of it, how those end use loads, let's say, operate. So behavior is really, really critical. I'm biased because I work in strategic energy management, but I really feel like energy efficiency problems are very often people problems as much as they are equipment problems. So always remember behavior and the system of decisions that happen around the equipment you're looking at. Use all your senses. One of the bummers about COVID has been finding that doing audits virtually, I don't get to feel the wind tunnel when I open a door. I don't get to, walk by something and feel the thermal energy coming off of it or hear something that's just screaming that tells me it hasn't been serviced in a long time. Use your senses because a lot of those things that seem wrong, that catch your attention because of the way they feel or the way they sound, are wrong and they're an efficiency opportunity. Set points mean more than equipment type. There was a point in my career, I told somebody they could have a $0 incentive for their VFD air compressor because it used more energy than the one they had because it was set up so badly. Think about that. Set points usually mean more than equipment type. So work with what you have. Don't just worry about, blowing something up and starting over when it comes to a boiler or a chiller or something like that. Did I mention behavior? Behavior. And then don't be afraid of any manufacturing or specialty processes. I know it seems like the temple of the production people sometimes if you're coming in from outside as an engineer, but if you engage with them, chances are there's a lot of opportunity in there. So don't get scared off. Think about things like scrap reduction and process optimization and opportunities within some of that kind of big, scary black box looking equipment. Okay. And then did I mention behavior? All right, Fred, let's move on to the next slide. So we can go one more. The 5 whys is a method of root cause analysis. So we talked about how finding the opportunity isn't as important maybe as doing something about it. Like it's not the hard part. And it's even harder if you're trying to treat the symptom instead of the disease when it comes to an efficiency opportunity. And that is super, super true when behavior is a thing, when behavior is a complicating factor in that efficiency problem. Now, I've thrown some examples on this slide, and if we go to the next slide, I'm actually going to walk us through a 5 whys example to do with space heaters, okay? So if I come in and see a bunch of space heaters in, let's say, in an administrative area in a manufacturing plant, I have to ask the question, well, why are they there? If you want to click for me, Frederick, there are some basic questions or basic answers to that, right? Like there's the nah duh one that's okay, somebody was uncomfortable. And then there's the more subtle one, which is, well, somebody was uncomfortable and they were pretty sure they wouldn't get in trouble for bringing a space heater in, right? There's kind of a subtext there. And if you keep clicking, Frederick, we can start to ask more questions. Why were they uncomfortable? Well, maybe it was actually too cold. Maybe there's somebody who gets cold more easily, like women. I got a blanket on me right now. Or because there's a bunch of airflow right over somebody, which can make it feel colder, even if the air is the right temperature. We can tackle the socially acceptable thing. So maybe, nobody really understands how expensive it is to run a space heater. Or maybe nobody understands that they can trick thermostats and then throw off the whole HVAC system. And obviously, nobody with a bunch of sway in this organization has ever fussed about space heaters if we've got a bunch of space heaters. Let's keep going. So, the people in authority might not have made a fuss because they didn't get the cost thing either, or the safety implications, right? You get the EHS person involved with space heaters and things change real fast, right? And then also there could be just a basic maintenance issue. The space temperature could be cold because there was already a space heater there, so we've got a cycle that's exacerbating. Or, maybe the thermostat's in the wrong place, or the thermostat's bad. So all these bold things are what I would consider root causes. Now, does it feel a little bit more reasonable that it's tricky to tackle space heaters? There are a lot of root causes going on. So always take a second to ask why when it comes to, a behavior-related efficiency opportunity. So I'm going to have you guys do a quick poll because I've got some top fives that we're going to go through, but I don't have a lot of time. So I want to make sure we focus on the right ones. So if you guys could click one to tell me which of these energy systems you're least comfortable, that you could find an opportunity in. So have a click there. Only 4% of you have voted. Come on, guys, give me some clicks here. All right, right now we have boilers and steam taking second place to chillers and refrigeration. You guys seem to be more comfortable with HVAC, a little more comfortable with compressed air. All right, right now boilers and steam is in the lead. All right, last chance to vote. 5, 4, 3, 2, 1. Close it up. So right now it's an even split between boilers and steam and chillers and refrigeration. So that's where we're going to focus. So if you want to advance there, Frederick. So let's talk about specific opportunities in particular systems. So opportunity number 0 that applies to everything is basic maintenance. Isn't that depressing? All of that stuff that your maintenance techs have already probably on their preventive maintenance lists, that is the efficiency opportunity to start with for all of these systems. Doesn't matter what it is. That's the basics, like proper belt tension. Doesn't matter what kind of belt you got on something. If it's tensioned poorly, that trumps belt type far and away, right? Filter changes, lubrication, leak detection, vibration analysis, all that stuff. Now, this picture I have up here, I have here because look at it. That's an air-cooled compressor that has one of the filthiest intake filters I'd seen in a long time. And you see the pile of fresh filters right there. Would have taken somebody like 30 seconds to change it. It's right there. And they hadn't. So why? So Frederick, if you can click a couple times. So if you're struggling with maintenance, I would ask a couple questions. One is, do your PM systems and your work order systems get not just the urgent stuff done, but the important stuff done? So if you look back or if you look at maybe the overall condition of your equipment over the past year, are you really getting to the fundamental PMs that are going to help your major equipment run right? And if they aren't, you need to revisit those systems. Another thing you can ask is, am I just so understaffed that it would be worth carving out pieces of this to hire out to somebody else? Ultrasonic leak surveys, those are cheap. It's usually well worth the money to hire that out and save your own technicians labor for fixing the stuff. So worry about the follow through. The detection can go to somebody else. So let's move on to our top fives. So chilled water systems and refrigeration was one of our ties for the lead here. So I'm going to throw out a few quick tips here. So chiller power is usually proportional to lift. And lift is the difference between the hot side, so that condenser, and the cold side, which is essentially your chilled water, right? So if you make your chilled water a little less aggressively cold, your lift goes down. If you help your chiller reject heat a little better, whether that's by keeping the air fins cleaner or whether it's by running your tower a little harder, you reduce lift. So that's a really, really good thing to remember generally for towers and refrigeration. Keep a good eye on sequencing too. It's a little hard to think about how to sequence VFD chillers if you're used to sequencing constant speed chillers. To always understand the part load efficiency map of everything before you go and sequence it, and then follow up and make sure the sequencing actually worked and did what you want it to do. Keep it clean. I see a lot of filthy cooling towers, and that means really bad water distribution and really bad heat rejection. So you're not going to get as cold of water out of a filthy tower as you are out of a nice clean tower. And you're probably gunking up your condenser on your chiller too, which means a hotter hot side on your chiller, which is poor lift, poor power. And then if you can get out of using a chiller, don't use a chiller, use a cooling tower. They use something like a fifth or a sixth of the energy of a chiller, which is pretty cool. All right, Frederick, let's go forward a little bit to the boilers one. So let's skip this guy since you guys seem to be compressed air ninjas. Let's talk about boilers and steam. My top five that I see is insulation. A lot of people insulate once and then they start having valves that need to be worked on or pieces of pipe that have to be touched up in some way, and the insulation never gets put back on after the maintenance. So insulate once, but always have a plan for re-insulating every time you need to get into that piping. Steam traps, steam traps, steam traps, steam traps, steam traps. They're a huge one. And steam leaks too. I see plenty of those guys. And there are lots of juicy incentives out there for both of those things. So create those nice preventative maintenance cycles. Tune-ups are amazing. And then I'm going to say water treatment again. Just like a dirty cooling tower doesn't exchange heat well, dirty boilers don't exchange heat well. So love your water treatment vendor or ditch them and get a new one. And then let your condensing boilers condense. Okay. Now we're going to skip the HVAC again because you guys are ninjas on that. And we're going to leave a little time for questions. So what kinds of questions do you guys have? And feel free to offer me your wisdom too.
Yeah, just a reminder, there should be a chat bar to the right that you can put your questions into, and we'll take those and have Claire answer them. I guess one question that I have, and this is coming from someone that's in marketing, not someone that really understands all the ins and outs of this, but there was misapplication and sub-optimized efficiency. Do you mind just touching on what the difference is between those two and where you would delineate?
That's a really good question. I would say sub-optimized efficiency isn't necessarily about using the wrong type of equipment. It's just maybe the equipment is worn out, the equipment is oversized. So I'm using a pump where a pump needs to be used, but it's just not the right, size or condition of pump. That's where I would kind of draw the line on that one. But all of that is just a way to think about the opportunities. Plenty of people have different little buckets that they use in their heads, and that's totally fine. There's no one right way.
Great. Again, to the right, there should be a questions bar. So if you have any questions, feel free to put those in there. We'll leave it open for about another 30 seconds and then we'll move on if there's no questions today. All right. Um, well, thank you, Claire. This is a lot of really good information. We'll be sure to be watching the chat bar online. If there's any questions, feel free to put them right on the website and we'll get those questions to Claire and she can follow up with you. So again, thank you everyone for attending today. We're gonna have our next presentation next Tuesday. It'll be with Terrence Tarantine. He's the director of HVAC sales with Young Supply, and he's gonna be talking about heat pumps and some of the ins and outs. A high level informational presentation on what benefits those can give to your organization. Again, that's on November 3rd at 10 a.m. You can register at mienergyconference.com. We'll be sending out an email on Thursday as well that you can register through. So be sure to be on the lookout for that. Again, thank you for attending and thank you, Claire, for presenting today. We hope you find this helpful. And if you have any questions, send them our way. Have a good rest of your day.